Researchers have tracked down that a thick layer of jewels might exist many miles underneath Mercury's surface. The first time we get to circle Mercury, we envision life on different planets. We need to imagine that the climate on those planets will determine what the creatures might look like. There are enormous mysteries hidden on a little planet near the Sun, Mercury. Small and hot, it has deceived us for a long time, yet now robots in space have discovered some odd things. They say they have found precious stones on the hottest world, and that's just the beginning. The inside of Mercury is unusually large. How is it different from other planets? What else does Mercury hide? Astronomers and people who are inspired by space have always been fascinated by Mercury, the smallest planet in our solar system. Its puzzling landscape was hidden from view for many years, and its mysteries didn't start to emerge until space research made significant progress. In 1973, NASA's Mariner 10 mission began the search for answers about Mercury's mysterious surface. In 2004, the Messenger probe continued the investigation. We got our first close look at Mercury when Mariner 10 was the first spaceship to visit it. It took photos of a landscape with craters and strange lines during its flybys, which looked a lot like our moon. This mission showed that Mercury's surface was rough and full of holes. It also showed that Mercury had an unexpectedly strong magnetic field and a core that was larger than expected. Researchers' past ideas about Mercury's composition were questioned by these discoveries. The Messenger mission, which stands for Mercury Surface, Space Environment, Geochemistry, and Ranging, began 31 years after Mariner 10 and helped us learn much more about Mercury. Unlike its predecessor, Messenger was made to go into orbit around Mercury so researchers could find out more about the planet. Messenger took an astonishing 200,000 pictures during its mission, revealing parts of Mercury that had never been seen before. One of the most fascinating things that Messenger found was that Mercury's darker side had surprisingly high amounts of calcium and magnesium, making scientists wonder about the processes that could cause such quantities. The mission also discovered that Mercury's magnetic field was stronger than usual in the north, which was different from other planets. Researchers found that Mercury's structure and formation process are entirely different than they initially thought. On Earth and most other planets, magnetic fields are created when liquid iron moves around in the core. But Mercury's magnetic behavior is different due to its unique core structure. What else makes Mercury's surface unique? Not only does it have craters and ridges, but it also shows signs of heavy wear. Mercury can get very hot during the day, up to 486 Kelvin, which is hot enough to melt lead, then drop to a freezing 100 Kelvin at night. These huge temperature swings are caused by Mercury's thin atmosphere, which doesn't help maintain stable or even temperatures. Although Mercury exists in an extreme environment, new studies have found some fascinating things on its surface. In 2012, Messenger data showed that Mercury had volcanic activity, including pyroclastic ash from explosive volcanism. Long-held beliefs that Mercury was geologically dead were challenged by these findings. Even more surprisingly, in 2020, researchers announced they had found water ice in some of Mercury's polar craters. Even though Mercury is close to the Sun, these areas are mostly in shadow and are cold enough to preserve water ice. This discovery has led scientists to wonder if Mercury could harbor simple life forms. Could there be extremophiles living in these icy areas, similar to those that thrive in harsh places on Earth? The Bepicolombo mission, launched in 2018 by the European Space Agency and the Japan Aerospace Exploration Agency, is scheduled to arrive at Mercury in 2025. This mission should provide us with even more detailed information about Mercury's surface, such as its chemical composition and geological history. From having a magnetic field stronger than thought to having water ice, Mercury continues to surprise us. But what we're going to discuss next may amaze you even more. Since Mercury is so close to the Sun, why is it that its year is shorter than its day? How can a day last longer than a year on this small, hot world? Let's break this down. It only takes 88 Earth days for Mercury to orbit the Sun once. Our year is much longer than a Mercurian year because of how fast it travels. A day on Mercury, or one full rotation on its axis, lasts 176 Earth days. Despite the fact that it is a major planet, Mercury's center is shockingly huge, which is one of its most intriguing secrets. A study led by planetary researcher Dr. Nancy Chabot at the Johns Hopkins Applied Physics Laboratory found that Mercury's core makes up around 85% of the planet's volume. Earth's core, which only makes up around 15% of the planet's volume, is much smaller than this. But why does Mercury's core weigh so much? One theory is that Mercury may have been a much larger planet in the past, but most of its outer layers were destroyed in an enormous collision early in the history of the solar system. Dr. Eric Asfog from the University of Arizona proposed this idea, also known as the hit-and-run scenario. This theory suggests that a large planetesimal may have hit Mercury and stripped away part of its mantle and crust, leaving behind the iron-rich core we see today. The peculiar magnetic field of Mercury is another profound mystery. Venus and Mars don't have global magnetic fields, but Mercury does. Its magnetic field is around 1% as strong as Earth's, which surprised researchers when NASA's Messenger mission made the discovery, as they didn't think a small, slow-rotating planet could have a magnetic field. Led by planetary researcher Dr. Katherine Johnson of the University of British Columbia, the team found something even stranger about Mercury's magnetic field. The field is about 20% of Mercury's radius away from the planet's center. This discrepancy could be because Mercury's shell isn't uniformly thick, which affects how heat flows from the planet's core. In 2020, researchers also discovered sulfur, potassium, and sodium on Mercury's surface, elements that could change rapidly. It was surprising to find these elements on a world so close to the Sun, as they normally evaporate quickly at high temperatures. Dr. Patrick Peplowski from the Johns Hopkins Applied Physics Laboratory suggested that these volatile elements may have come to Mercury from comets or asteroids after the planet was already formed. One of the most intriguing recent discoveries about Mercury is that it has water ice in craters that are permanently shadowed near its poles. We mentioned Dr. Nancy Chabot earlier. She also worked on this study. Despite Mercury's proximity to the Sun, the ice remains because these craters never receive direct sunlight, keeping the temperatures extremely low. The findings become even more fascinating with the discovery of organic compounds alongside the water ice in these craters. These dark deposits might be made of complex carbon-based chemicals similar to those that could have helped make life possible on Earth. Despite Mercury's harsh conditions, could it hold clues about how life began in our solar system? Another significant mystery about Mercury is its unusual interaction with its rocks. For a long time, scientists believed that Mercury was a geologically dead world. However, data from the Messenger mission showed signs of volcanic activity that occurred not too long ago. Small, bright spots on Mercury's surface, resembling volcanic vents, were discovered by Dr. David Rothery from the Open University in the UK. These shapes, called hollows, suggest that Mercury may still be geologically active. One of the strangest features of Mercury is its chaotic terrain, a vast area of jumbled hills and valleys near the planet's south pole. The Mariner 10 mission first observed this region in the 1970s. About the size of Texas, this landscape may have been shaped by massive quakes triggered by the Sun's gravitational tides as Mercury's orbit changed, according to Dr. Thomas Waters from the Smithsonian Institution. New studies have also unveiled fascinating insights into Mercury's composition. Data from the Messenger mission allowed Dr. Amir Khan from the University of Zurich to explore Mercury's internal structure. His team found that Mercury's core likely has a liquid layer on the outside and a solid core inside, similar to Earth. However, Mercury's inner core is much larger than Earth's, which could help explain some of the planet's unusual magnetic properties. These deep secrets about Mercury make us question how planets form and evolve over time. They remind us that there are still many mysteries to be solved in our own galaxy. As we look forward to new missions and discoveries, we can't help but wonder what else might be hidden beneath the cratered surface of Mercury. The mysterious depths of Mercury, the recent findings and ongoing missions, are showing that the deepest parts of Mercury are just as puzzling as the surface. One of the most intriguing things about Mercury's innermost parts is how it is structured. Earth's core is solid in the center and liquid around it, but Mercury's core is mostly liquid with a solid aspect in the center, as confirmed by NASA's Messenger mission. Earth days. This is where things get truly fascinating. A year on Mercury is, as it were, half a day. Some abnormal things happen along these lines. Bizarre circumstances. On the off chance that you had a chance to stand on Mercury's surface, you would see the sun rise and get larger overhead as it crosses the sky slowly. The sun would appear to stop at a certain point, then move backward for some time before returning in the same direction it came from. Mercury's rotation can't keep up with its fast orbit, which is why it does this strange dance. But why does Mercury turn so slowly? It's believed to be due to something called tidal locking. Earth's rotation has slowed down over billions of years due to the sun's gravity. However, Mercury isn't in a neatly locked orbit like the Moon is. Rather, it is in a 3:2 spin orbit resonance. In other words, it rotates 3 times for every 2 trips around the sun. This peculiar pattern constantly has exceptionally intense effects on Mercury's surface. The side facing the sun is extremely hot for long periods, while the side facing away remains freezing for the same amount of time. Some of the greatest temperature changes in the solar system occur because of this. When we discuss Mercury's atmosphere, or lack of one, it's vital to note that the thin atmosphere it has is called an exosphere. This extremely thin layer of gases is constantly losing gas into space and gaining new gas from various sources. Mercury's exosphere is kept alive by the solar wind, atomic decay, and even micrometeoroids hitting the planet. Some amazing aspects of Mercury's exosphere have been discovered in recent studies. Researchers using data from the Messenger mission found in 2020 that Mercury's exosphere has more water vapor than previously thought. It's believed this water vapor forms when hydrogen from the solar wind mixes with oxygen in Mercury's surface rocks. The way Mercury's short year and prolonged day affect the planet's magnetic field is also very intriguing. Scientists were surprised to discover that Mercury has a magnetic field, even though it is small and rotates slowly. New research suggests that Mercury's magnetic field is caused by a dynamic dynamo effect in its liquid metal core, which is due to the planet's unique orbital and rotational characteristics. Although it's much smaller than Earth's, this magnetic field is crucial in protecting Mercury's surface from the harsh solar wind. Mars would lose even more of its atmosphere even faster if it didn't have it. Because Mercury's orbit is fast and its rotation is slow, some interesting phenomena can be observed on certain areas of Mercury's surface, known as hot poles, where the sun seems to pause overhead. These hot poles experience the highest temperatures on the planet. On the other hand, some regions near Mercury's poles never receive sunlight. Scientists have found evidence of water ice here, which mostly exists in the shadows. But how does ice survive on a planet so close to the sun? This is possible due to Mercury's unique orbit and rotation. Permanently shadowed craters near Mercury's poles never receive direct sunlight, keeping them cold, while nearby areas get extremely hot from the sun. Scientists are now investigating whether these cold traps might also contain other volatile substances like organic molecules. Mercury's short year and extended day also impact how we study the planet. Spacecraft face challenges getting to Mercury because it moves around the sun so quickly. To slow down enough to enter orbit around the planet, they need to perform complex maneuvers, like flying by Venus and Mercury multiple times. The Bepi-Colombo mission, currently en route to Mercury, will use these gravitational assists to gradually change its speed and trajectory. The spacecraft was launched in 2018, but it won't enter orbit around Mercury until 2025, after flying by 9 other planetary bodies. Once Bepi-Colombo reaches orbit, it will face another challenge due to Mercury's unusual day-night cycle. The spacecraft must carefully manage its exposure to Mercury's intense daytime heat and maintain enough power during the long, cold nights. This delicate balance is crucial for the mission's success and highlights the harsh conditions on Mercury due to its unique orbit and rotation. New computer models have provided fresh insights into how Mercury's rotation rate evolved. Based on these models, Mercury might have rotated much faster in the past, but the sun's gravity and impacts from large asteroids or comets slowed it down. Not only does this study help us learn more about Mercury's past, but it also gives insights into how other planets in the solar system might have changed over time. As we learn more about Mercury, new questions arise. How does the planet's core remain partially liquid despite the long, frigid nights? How does Mercury's unusual orbit affect the rocks that make up its surface? It's fascinating to think there are still many mysteries to be solved within our own solar system. Mercury's unique characteristics lead us to consider how planets form and change over time, prompting us to expand our theories and explore new possibilities. What other astonishing secrets might Mercury be hiding beneath its harsh surface? Despite being the smallest planet in the solar system, Mercury conceals a wealth of oddities, and scientists are still captivated by its unusual and rare attributes. This weird center arrangement utilized little changes in Mercury's gravitational field to make a guide of the planet's interior. It's believed Mercury's solid inner core is about 1,260 miles, 2,000 kilometers, wide, which is nearly half of the planet's total core. This is significantly larger, proportionately, than Earth's inner core, which only makes up around 20% of our core volume. Its magnetic field is surprisingly strong for such a small planet, though it's much smaller than Earth's. It depends on the size and shape of Mercury's core. The mantle beneath Mercury's rock isn't as dense as once thought. Earth's core is about 1,800 miles, 2,900 kilometers, thick, but new studies suggest Mercury's may only be about 260 miles, 420 kilometers, thick. This thin layer changes how Mercury's rocks move and how heat is dispersed. In 2012, the Messenger spacecraft found evidence of ancient volcanic activity on Mercury's surface, one of the most intriguing discoveries about the planet's interior. Odd shallow depressions called hollows were found by the spacecraft, appearing to have formed when volatile elements rose to the surface. These hollows suggest that Mercury's core used to contain more volatile elements than scientists initially thought. Using data from Messenger, scientists made another important discovery about Mercury's surface in 2020. They found evidence of a vast underground magma ocean that likely existed a long time ago. This ancient magma sea probably played a significant role in shaping Mercury's surface and interior. Mercury's surface has some interesting features, like the large smooth plains covering much of its northern hemisphere. This ancient magma sea could explain these features. It's thought that these plains, known as the northern volcanic fields, were formed by massive lava flows early in Mercury's history. Yet, one of the most astounding discoveries about Mercury's surface came in 2022. Researchers analyzing Messenger data found evidence that nitrogen was trapped beneath Mercury's surface. This nitrogen might be remnants of an ancient atmosphere, which was pushed underground by the planet's intense heat and solar radiation. The fact that nitrogen is found beneath Mercury's surface raises intriguing questions about its history. Could Mercury's atmosphere have been thicker in the past? If so, what might this mean for past temperatures and the planet's potential to host life? Water ice can be found in permanently shadowed craters near Mercury's poles, another fascinating aspect of its deep interior. This ice lies on the surface, though it's invisible because it's so cold in these regions, which are mostly shaded. Some of this ice might be relatively recent, possibly delivered by comets or asteroids over the last few million years, according to recent studies. In addition to water ice, these polar craters contain dark deposits that experts believe may be organic compounds. There's a possibility that these substances, more volatile than water ice, originated from comets or asteroids that struck Mercury. These organic materials have been preserved in Mercury's subsurface, enabling scientists to study how organic molecules are distributed throughout the inner solar system. Mercury's tectonic plates past can also be found beneath the surface. Although Mercury doesn't experience plate tectonics like Earth, there is evidence the planet contracted as it cooled over time. Many thrust faults formed due to this shrinkage, where one part of the crust has been pushed up over another. These faults, which can be several kilometers high, reveal details about Mercury's subsurface composition and formation. A recent study of these thrust faults has shown something remarkable. Mercury may still be tectonically active. As part of a recent study, small features called grabens were discovered near some of Mercury's largest faults. These grabens, essentially small valleys formed by the crust stretching, seem to have formed recently, suggesting that Mercury's crust is still shifting and settling. One of the most mysterious aspects of Mercury's deep interior is its magnetic field. Earth's magnetic field is generated by the movement of liquid iron in its outer core, but Mercury's magnetic field is thought to arise from a different process. Some scientists believe it could be caused by a dynamo effect in a thin layer of liquid metal surrounding a solid core. Another unusual aspect of Mercury's deep interior is the possibility of faults and fractures beneath the surface that could allow heat and potentially liquids to move through the planet's crust. Some experts think there could be pockets of liquid water deep beneath Mercury's surface, though the planet is extremely dry. Heat from Mercury's core is believed to keep this water in liquid form. Though it may seem unlikely that Mercury has water beneath its surface, similar phenomena have been observed on other planets in our solar system that don't appear to be habitable, like Europa, Jupiter's moon, and Enceladus, Saturn's moon, both of which have oceans beneath their icy exteriors. Despite Mercury's harsh environment, the possibility of water beneath the surface is still conceivable. As we learn more about Mercury's innermost structure, new questions arise. How has Mercury's interior evolved over time? Could there be other trapped gases or chemicals beneath the surface? What could the deepest parts of Mercury's interior tell us about the early history of our solar system and the forces that shaped the inner planets? These questions underscore the importance of continuing to explore Mercury. Every discovery about its deep interior not only enhances our understanding of this incredible world but also provides valuable insights into how planets form and change over time in the solar system. As we look forward to new missions and discoveries, one thing is certain: Mercury still has many secrets to reveal. Even though it is small and close to the Sun, its deepest layers hold clues about its past that may unlock insights into the history of our entire solar system. What a journey! Share your thoughts on what you think we might soon uncover on Mercury. Could it be valuable minerals or even evidence of life from elsewhere? Please click the like button and subscribe to the channel if you enjoyed the video. That way, you'll never miss any new content. Take care, and we'll see you in the next video.